So my session is called Fail Happens. My name is Marcin Sodkiewicz. I'm community builder in serverless area. Apart from that, I'm running user group in Wrocław, in my hometown. And today I'm going to talk about the failures that can happen in the event-driven architectures. So I'm going to talk about integrations with the SQS and the Kinesis and all bad things that can happen to your system. Also how we can monitor that situations, some pinch of the cost and the chaos engineering. So first, let's understand how it happens that our Lambda is getting message from the queue. So basically, it's getting into our handler. Then we can call our third party. So it might be database, third-party system through API, whatever. And then we are acknowledging that we have processed the item, and we are deleting that, and it's considered a success. So how it happens that this message is going in general to our Lambda? So we have our sources of the events, and we have the component that lives inside the AWS Lambda itself. It's not our function. It's some part of the AWS Lambda service that will poll that sources. It can also then filter them. It can batch them, so we can have processing of bigger parts of the events from our source. And in case of some of the sources, it can do a lot of heavy lifting, like bisecting, running tumble windows, controlling your concurrency, doing retries, and so on. So this service is great. And in general, if you are working with the Lambda and you're consuming these sources, most probably you don't even know what is the API or SDKs for the loading those informations from those services, like, for example, how to integrate with Kinesis data streams. And then this event source mapping is sending synchronously that payload to your Lambda. But life is not always happy, right? Sometimes we have failures. And in that situation, what might happen? If we have the malformed item, and we know that it's malformed because it's, for example, there's wrong contract on it, processing that message over and over, it's insane, right? So what we have to do is that we have to do something to not repeat that failure over and over. So what we can do with such message, we can either drop it, we can retry it, or we can send it to the letter queue for further investigation or handling in another way. So first of all, let's take a look at the drop situation. So we are taking this message from the queue. It's getting into our handler, and we know that it is malformed because, for example, it's invalid or contract is not matching whatever we are expecting. So repeating that message doesn't make a lot of sense. So what we can do is that we can just drop this message. So we are returning OK from our Lambda handler, and event source mapping will remove that message from the SQS queue. But we need to make sure that it is audited and that this message is for sure useless. What we have another option to do is running that on the letter queue. So in that case, how we are configuring that? We are setting up on the SQS information about how many receive counts our message will be sent over to the dead letter. Then we are retrying and repeating processing of that message because let's say that there is some temporary issue or something wrong is happening. Not always that message is malformed. And after reaching that max receive counts, SQS on our behalf will send that message to the dead letter queue. Usually it is for the unknown issues. What also might happen is that we have a message, we are picking it from the queue, and let's say that it's malformed, and we know about it. We know that can do anything, and we don't want to drop it. Maybe we want to send it to the letter queue because our dead letter policy is that someone will pick it up and, for example, do something manually, or we need to investigate that case. In that situation, we can send that message on ourselves to that letter. Because let's imagine the situation that we have max receive count 200. Repeating that scenario that we know that it's failed for 200 times makes no sense and might be costly. The same situation might happen if we are processing this message, and based on the response from our integration that we have with our third party, we know that it will be better anytime soon, right? Because it's just the way that processing is working. So key things about the dead letter. When message is going to the letter, we have up to 14 days to pick it up. After that, there is a retention period that expires on that message, and this message will be deleted from the queue, and we will lose it. So what we have to do before that time is that we have to store it and potentially replay it in the future, or even right now. But we have to remember about a few things. One, temporal coupling. So in case that we are loading this message, we are loading data from some third-party system, and we are doing some action based on that, it might change over time. So if you're replaying that, it might be changed. For example, it might be tax value or something like that. Another thing is versioning. So our events has to be versioned. If we are playing that after a long time and something has changed with our service, it might be not processed, for example, or processed in a different way if we are not having versioning on our events, so it's critical. Another thing is ownership. So every letter queue must have an owner. Someone has to pick up that messages, and someone has to be responsible for it. It might be department, might be team, might be person, whatever, but someone, some entity has to be responsible for it. And also, it's important to have alerts on it. In distributed systems, we have plenty of letter queues because we have plenty of queues, and our architectures might be quite complicated. So we don't want to have dashboards and watching them over and over, right? We just want to be alerted that something bad happened. And what we have to watch, in my opinion, in the letter queues, there are two key things. One is how many messages are there. So we won't have 0 messages on the letter queue, obviously, and also for how long these messages are there. So if message is going dangerously close to the retention period, we might lose that message and lose that information. So it's something that we can't have in our system. Okay, but to make sure that someone will get this alert, even we have set it up, imagine the scenario following on the screen. So on the very beginning, we have failure that started. At the end, it got resolved. But to make sure that this failure was resolved over the time, we need to make sure that someone will be alerted and will do some action. If in the meantime we had some attacks, outages, someone has set up too eager alarm and our inbox is full of the messages, most probably developers, what they do? Nothing. They are just skipping those messages, they are deleting them, and they then don't care. So what we can do for that situation is that what we can set up is that after alarm, we have information about on the event bridge. What we can do then is we can start a function that can periodically go and check if our alarm is already in the OK state or it's still in alarm state. In case our alarm is still in the alarm state, what we can do is that we can retrigger the alarm actions and remember people who are responsible for the letter queue that they have to do something about it. And it's super important to always have that letters. Remember about it. Whenever you're setting any event-driven system that has option to put the dead letter, do it. In my opinion, it should be not even optional. OK, but even if you have the letter queue, are you safe? Is there no chance that you will lose your message? There is, but let's start slowly. So if you have event source mapping that I have described at the very beginning, it works in a way that it's polling that messages from the SQS, and then it's evoking our function. And we can control here two things regarding the concurrency of processing. One is result concurrency, so it's the cap of the how many concurrent executions on our Lambda is available for AWS to invoke. And other thing is maximum concurrency. So in that way, we are saying to the event source mapping how many invocations on our Lambda at the same time might be invoked. OK, so back in the days, there was only option to have reserved concurrency control. So if you have cap on processing, because you don't want to too quickly process some stuff, let's say we have some, we're calling some third party, and we don't want to put too many requests at the same time, we could control it over reserved concurrency. And how it works that when our event source mapping is taking messages from the queue, it's trying to assign to the function. But if you have reserved concurrency to 10, like in this example in this article, then what might happen is that there is no free Lambda to assign it to, then this message is going back to the queue. And it's treated like a normal failure. So it might happen that your message, in the worst case scenario, was not even processed once on your Lambda, and it's landing on the letter queue. But it's not that bad scenario, because there might be something worse. In case if you have lots of messages to be processed, and those messages can be assigned to this Lambda all the time, and we are not reaching this max receive count, so it's not going to the letter queue, this message might be gone. So there is a, in theory, situation that even if you have the letter, your message will be gone. OK, and what we can do here, we can add maximum concurrency. So it works in a way that our event source mapping is understanding that what is our maximum cap on the concurrent execution, and it will be processed, everything will be fine. But there's one exception here, that if you have not enough free executions on your whole account level, then it might happen that your message will have the same problem that we're just describing with the reserved concurrency, right? Because it still can't invoke the function, it's still going back to the queue, and the same situation might happen with the retention. So my two advices here: don't skip on retention. If you want to have some kind of limitation of retries, or you can want to have some limitations regarding the time of processing that message, you can put it on the contract level. And it is really important right now. So this is the article from last year. If we will zoom in, then at the last reInvent, scaling of our event source mapping has changed. So previously it was 60 concurrent executions, up to 1,250 concurrent executions, but right now it's 300 concurrent executions every minute. Okay, and right now let's talk about the retries. So before going to the retries, how it happens that this message is retried. So whenever our message is going to the handler, then clock starts, and we're calculating this visibility timeout. After it elapses, the message is visible to any other consumer. So message is going back to the queue, and it can be picked up by the other instance of the Lambda. So it is validated only on the event source mapping updates, and it's not validated if someone will change the configuration of the queue. So it's super important to keep an eye on it. And whenever we're retrying those messages, what we are hoping to is that this third party at some point will be up. Maybe we were throttled, maybe it was some temporary issue, maybe something changed on the network, which was something small change. But what it also might happen, that we are calling this third party, and it's not getting any better. It's just having severe outage. So what we might do then is that we can, as a first idea, try to implement backoff. So it works that instead of retrying the same message in a fixed period of time, we can calculate this backoff exponentially and do it in the more and longer period. And it's also important to apply jitter here. So what we are doing is that we are applying randomization component to calculation of our next retry. Without jitter, what we are having is that we are having the spikes of requests in the fixed amount of time. With the jitter, we are trying to uniformly distribute it over time and trying to reduce the risk that this failure will happen again after the next retry. How we can do it? So on the SQS record that we are getting, we have fields with attributes. We have the information about approximate receive count. So how many times this message was tried to be processed. Then what we can do, that we can just take it from these attributes and we can compute it. So we can compute this exponential value of the next retry. We can add a jitter to limit the chance of doing that in the same period. And what also is important to add the max value in there, because since we are calculating this next periods with the exponential component, it might grow really, really fast. And then on the same record, we are getting the receipt handle. And this is the value that we can use in the SQS SDK to change message visibility. So this is how we are overriding and having those increased periods of time of the next retry. But we might ask ourselves, have we changed anything right now? What we have improved is that we have better retries distribution. We have lower risk of reaching those max retries and thus this message sent to the letter queue. But we are still calling our third party hard because we have highly distributed system, we are calling it a lot. And what is worse, that we have this kind of response time distribution. So it's up to our timeout, and we are paying lots of money for it as we are charged for GB hours when we are consuming Lambda. So what we might introduce at that point is to add the circuit breaker. It's the approach that basically, when we are calling our API and everything is working fine, we are just calling it. As soon as it started to fail, we are not calling our third party anymore. And from time to time, we are switching to this half-open state. So this is the state in which we are sending those scout requests that will check if our dependency is up or down. If it's up, then we are getting back to the business. But in case that it's still down, what we are doing, we are tripping this circuit breaker open, and we are not calling it anymore. What is an effect of that is that response time distribution. So on the maximum, obviously, it will be the worst case scenario. But in the higher percentiles, in this kind of lots of requests, we won't be waiting and paying for it. And also what is better, we are not killing our third party. Okay, and how we can implement that? So my recommendation is to use this general purpose circuit breaker. So it's like normal circuit breaker implementation, but with a distributed state. It's super granular. It has fallback support because we are doing that in our code. We can even have a backup system. It's very versatile because we can use it in any type of the integration. And if you want to keep your storage somewhere, you have to be aware of one thing. Since it is based on the rate of the failures, we have to do the persistence of failures after every request because it's based on the rate, right? So in case that we have high throughput system, there are two ways that if we are having VPC, we can use Elastic Cache. If not, we can use Momento Cache. In case of low throughput system, we can use Momento or DynamoDB, but we have to be aware that DynamoDB might get costly in case that our traffic will grow. And also, we can use Momento or Elastic Cache. There's another way that we can do it, and is this way of what I call it special purpose circuit breakers. So it works in a way that we are implementing our circuit breaker by manipulating our event source mapping. So basically it works in a way that we are observing metrics that are emitted by our Lambda function. It can be picked up by the event bridge, and then we can run Lambda that will modify our event source mapping. There is one risk here that it can be potentially expensive in case that we are not using the metrics that are given to us by the AWS for free in the high resolution, but if you want to have some custom metrics. Okay, so the idea is that we will use the CloudWatch alarm state as our state of our circuit breaker. So in case that everything is okay, our circuit is closed. We are calling our third party as the full speed as we have enabled ESM. In case that our system will start to fail, our alarm will be in alarm state. Then we are disabling event source mapping. So we are not taking any messages anymore, and we are not calling our third party. At that point, we have no metrics. If we have no metrics, we are going to the insufficient data state, and then we can enable our event source mapping again, but we can put the maximum scaling to the minimum value of 2. So that will be our scout requests. It will be rate-based. There is no storage. There's only one risk in case that our third party will be for a really long time down. As long as our retention period, we can lose those messages. And this is how it looks like on the CloudWatch. So as you can see, if our alarm is in the alarm state, so those are these red areas, then it's going to the insufficient data state. We are having some kind of calls. Then we have, again, alarm, and so on and so on. And at the point that we are disabling the failure, our alarm is getting into OK, and we are back to business. So right now, I was talking about processing of different types of the processing. But right now, let's take a look at the processing that messages in the batches. So what we can do is that we can have batch size equals to 1. It's really not a bad decision. It's low throughput, but it's super easy implementation. If you don't have competencies in your team, that's really not a bad decision. You can embrace the scaling of the cloud, and it won't be, nothing bad will happen. But what can happen bad is that you are going to the batch processing, and you can do it. So if you will take a look at the animation, how it works in a way that if our Lambda is getting on the input, from the event source mapping, the batch of the request, and even one of the items is malformed, failed, invalid, whatever error will happen in there, we are retrying the whole batch. In that case, we are paying for all the executions. We are trying on successes, and if you are using some third party that is expensive regarding calls, that might be really costly. Idempotency is always important in the event-driven architectures. But if you don't have idempotency in this kind of situation, it will be really bad for your system. So what we can do in that case is that we can switch the partial failures. We are no longer returning errors from our handler. We are reporting failed items. There is a contract that you have to follow that is given to you by the event source mapping. If you will break it, then the whole batch will be calculated as a success or a failure. We are losing errors metrics because we are no longer returning errors from our Lambda. That is something that is critical to understand. And we need to make sure that it's on. I know it sounds silly, but it's really important. From event source mapping point of view, you are returning some response. It doesn't care what it is. But in case that you will turn on this feature, it knows that it has to understand your contract and to only delete those messages that you want marked as failures. And here is how we are reporting the failures. We're just passing simple object with the array of item identifiers of the failed items. So how this implementation might look like. So we have some Lambda handler in Go. We are first parsing records, we are validating records, we are processing them, and we are returning failures. Looks very simple, but the problem with this implementation is that it's completely wrong. So what we are having here is that we have exactly the same issue that we had before. So if any message is malformed, any message is invalid, you are failing the whole batch. What we have to do is that we need to introduce some kind of funnel-like processing. So we are parsing records, and we are moving further in the processing only items that are not malformed. Then we are validating, we are passing only valid items to the processing, and so on, right? And we're reporting failures on every stage. And since we are processing items in batches, then usually we are processing items in batches also when we are sending data over. What might be also another option is that if we are doing that in parallel. But assuming that we are using some kind of batch API or SDK, it works exactly as we described with the partial failures. So it works in a way that we are always getting 200 OK. So I've seen way too much this kind of implementation that developers are only reacting to the errors in case of using batch SDKs. It's not working that way. In case of the DynamoDB, you are getting unprocessed items in the response. It won't be an error. Error will mean that, for example, there is some major failure on the service itself. But you will get unprocessed items that you have to handle specially. And in case of the services like SQS, SNS, and all shapes of forms of the Kinesis, you will get the information about the either identifier of item in the batch request or its ID. Even if you have these partial failures, there is still one issue that might happen that will fail whole batch and you will reprocess items all the time. Imagine the scenario that you are consuming some kind of batch SDK, and it has some maximum value. Like, for example, it can process up to 1 megabyte, right? And if you are sending there over the items, it works fine, everything was tested, you are going to the production. But then what it happens that you are adding one field to your payload, another field to your payload, yet another, and at some point, these messages are so big that your batch is just overflowing this limit of the batch SDK. So what you can do is, if you will take a look at the right animation, is that whenever we are seeing that our whole batch is failing, we can try to bisect that elements from the batch and try to process it again. There is no support for that kind of processing in the SQS. It is in the Kinesis. I mentioned before that our processing has to be idempotent. But idempotency is not everything. Sometimes it's also about the order. So let's take a look at the scenario of the processing FIFO. It gives us order and the duplication. But also what it gives us is the limited batch size of 10. So our throughput is hit by that. If you will take a look carefully at the animation, you can see that our items are not processed in the order. Because what we are doing, that we are just, with the same implementation, we are just reporting failures. But then if we are not processing those items in the ordered queue out of order, it makes totally no sense. So what we can do, as an idea, is we can fail fast on first item in the batch that will fail. But what will happen then is that we will lose items. Because if you are failing on the first item, and we are not processing consecutive items in the batch, then they are treated as the failures because we are reporting failures right now. So what we have to do is that we have to, after first failure item in the batch in the SQS FIFO batches, fail all the consecutive items. And we might ask ourselves, does it make sense to have this kind of small batches with this kind of limitations? Because maybe not. What we can do is we can switch to the Kinesis. Kinesis provides us order. Previously in the SQS FIFO scenario, it was based on the message group ID. Here we have the partition key, and we can batch those items up to 10,000 items. And we have one consumer per shard. It works in a way that not like previously in the SQS, we are, let's say, reading something from the queue, and we are blocking this item in the processing. Here we have this consumer per shard, and it has cursor, and is trying to iterate over the shard. Whenever there is a failure, we are repeating the processing of the item. In case there is success, we are progressing. And all of that is kept for us in the event source mapping, so we don't have to care about it. But what might happen is we have, again, malformed item, or invalid item, or something is wrong with this item. And this item will be reprocessed all the time for its retention period. By default, it's 24 hours. It's up to 1 year. So in that case, we have blocked shard. But what is worse in this scenario, that if our item is expiring and our shard will be unblocked after it will be removed from the stream, every item that is behind it most probably will also expire and we will lose everything behind that item. So again, it's super important to have dead letter queues set up. And you have to be aware that those dead letter queues are working a little bit different with the SQS. In SQS, we had just item on the queue. Here, what we are getting is that we are getting pointer to the stream, to the shard with this failed item. So what we can do in that situation is that we can report item failure destination. And it might be SQS or SNS. In case of the failure, it will be invoked either message on the SQS or it will be request to the SNS, and it can be picked up, for example, by our Lambda. In Lambda, what we can do is that we have to process this failure. We can send it over to another compute service, we can send it to over SQS, SNS, we can put it on S3. It's up to our dead letter policy. It doesn't matter, but we have to do it before its retention. So it's not like it can be on this queue and rot in there. No, we have up to time of the retention. And how to read these items? We are getting the information on the letter event about the request context, blah, blah, and we have also shard ID, start sequence number, and stream ARN. API is using stream name, but doesn't matter. We have to just pick shard iterator, and then we have information about how many items were failed in this batch, and load all of them. It's weird, right, that we have items, how many items were there, right? And this is because that is how it works processing items in the batches. So if you will take a look at the screen, when you are getting the batch of size 8, and item number 5 will be failing, then what we will get after retries that we have set up, on the letter queue, we'll have the pointer to all of that items in this batch, even the items that were successful and items that were not processed. So it's really important to keep that in mind. What we can do with a single Boolean is to add the bisection. So it means that on the failure, we are splitting in half our batch and trying process again, but we are not having to implement that ourselves like with the SQS, but it's given to us by the event source mapping. And right now, since it will be splitting up to one item, we'll have batch size 1 in case of the failure. Obviously, we can also add partial failures, right? It works in the same way as was with the SQS, with everything more or less the same. There's a different contract, that means a little bit different things, but I will go to that in a second. But if you will look at this animation and the animation that was previously displayed for the bisection, they're not that different, right? But only because of this example, it's only 10 items. But the difference is crucial. If you have batch size of size 100 and item number 90 will fail, in case of the bisection, what we will do, we will split that in half and we'll process first 50 items and so on and so on. We'll be processing a lot of successful items. In case of bisection, we are saying, okay, 89 items were successful. Let's keep processing again, starting from item number 90. And here's our contract. We are just reporting the sequence number of the failed items. And what is important here, it will just pick the lowest value and start from there. If we have implemented that everything correctly, we have implemented that. We are not sure if it's working or not. So what we have to do is that we have to test it right now. And how we can force third party to fail? It's kind of hard, right? So what we can do is that we can do chaos engineering with the AWS FIS service. In this article, we just describe this approach with using a layer that is based on the extensions API, and it works in a way that it's adding layer to your Lambda, then it injects some kind of failure, and it's keeping there for some time, and then it's just removing this layer. What we have in control here, we can just enable some type of the experiment, so either response fault or latency fault. We can also add the probability of how probable is that this will be injected or not. And in case of the latency, we can set the value for the latency. In case of the response, we can override the response. It might be tricky in case of the partial failures because it won't be dynamic, so we will only fail the whole batch, right? So it might be tricky to test it. What also we can do, if we don't want to override delay or the response, is that what we can inject simulator failure to the IAM. So in this article, there is described way of doing so. We are in FIS, we are executing SSM documents. So what we can do here in case of such experiment, that we can say which role we want to target, what is the policy that we want to inject, and it will be policy with the explicit deny, so it has like precedence over all of other rules, and we can just block some type of the communication. We are saying for how long we want to run this kind of failure, and role that will execute it. Then we have the steps, and we are attaching policy, running experiment, and detaching policy, right? Quite simple. But what if we want to do something else? Maybe we want to send malformed message to our stream or queue. What we can do there is that we can have special step that it will be based on the Python code. Since it's based on the Python code, you can do anything in there. And it can be also parameterized. So you can write it once and just parameterize it for your different workloads. If you want to check if during our test what is going on in our system, we need to have some observability. The signal that will work best in here are traces. We have the service map. Since we have highly distributed systems, that is the perfect choice. We have information about the status. We have information about the details of the execution. We can see how it was connected and how it was flowing through our systems. What is more, we can add the attributes there. So this is like your domain values that you will put there. Something that it's related to only your system. And it's just the way of having the conversation with your application. What is else in the tracing, that you can add the span events. So you can add the full details of the exceptions that were happen, I don't know, feature flags that were evaluated, maybe circuit breaker status that was changed, or anything else that you want doing there. But to have this beautiful workflows, how this communication is going through the systems, we need to propagate the information somehow. So one way of doing so is to use the W3C standard for doing so. And it is even supported by the cloud events. So in the cloud events standard, there is a place to put the information about the extensions, and there is also module for distributed tracing. So that way, if we are sending that over the payload, we can just pick it up on the consumer and just continue tracing from there. But it's not always the scenario, because sometimes we have contracts that we can't break. What we can do in such situations is that we can add this context of the processing to our attributes, in case of the SQS, for example. So first, we can just pick it up from our current processing. We can add it to the message attributes in case of the single or batch request. And then on the consumer end, we are picking those values up and continue our trace. This is exactly how AWS implemented that, for example, in the X-ray. So now let's consider some scenario. We have producer that is scheduling multiple tasks. Then we have some flow, and every X message will fail X times. If we do it in the way that I just described, what you can see is that you have really huge trace with everything in there, right? With all of those failures for every message. In case that our batch size will be 50, 100, then it might be crazy, right? That we will have the whole, all of those items in the same trace. It will be barely useful, and every time we'll look for some domain value, we'll see the same trace. What you can do is that you can separate those spans and those traces. So we can start the new trace before sending every message and adding new attributes. Then what we can have in our system, that we can have separate traces for all of that messages that were scheduled. And there is one benefit as well. So if we are having everything sent at once, we have sampled nothing or whole processing. In case of splitting that per task, we can have sample of it. Of course, not always we can split it. If it's the same big process that has to be tracked together, don't split it, right? The instrumentation of your code with the OpenTelemetry is just a matter of telling good story that will be understandable and useful for your team. But we can't base our operations on the traces, because we will have to watch them. And no one has time to do it. We have better things to do during our day. So what we have to do is that we can set up alarms for the processing. What I would recommend to watch is the processing lag. In case of the SQS and the Kinesis, it will be approximate age of oldest message, or iterate for 8 milliseconds. for our business values that have some KPIs to follow, right? And some SLOs. So another thing is to having these alarms for the retention, to just make sure that we won't lose any message, because that is critical. Just a reminder to set up those alarms for the dead letter queues and alarm for the throttles, but only for the severe ones. If we will have alarm that will informing us that any throttle in our system, it will be alarm fatigue, and no one will care about those alarms for sure. So it's important to have proper setups based on the multiple observations and to make sure that this issue is severe. And also, we have to have alarms on the scaling issues. In case of the Kinesis, for example, based on the read provision throughput. It means that, for example, if you have stream and you have more and more consumers of it, it might happen that it will be throttled because of the limitations on the shard. In that case, what we have to do is that we can add enhanced fan-out. There's also parallelization factor, but it will be more related to the iterator age milliseconds, so to make sure that we are effectively consuming our streams. And apart from that, there's auditability. So what I would recommend to use is the Kinesis data firehose. With this service, what we can do from our compute, we can just send the request to the Kinesis data firehose. In case of the Kinesis data streams, we can connect it directly to the data firehose. And it is a great service. What it gives us is gives us transforming to Parquet, to the columnar format. It can batch data for us, partition it, send it to the S3, for example, where we can control data lifecycle, access control through KMS, and encrypted address, and also do analysis. And also, if you have the system that you are building based on the event sourcing, you might have a better option to do so. But if not, I would advise to add this kind of audit. And the last thing that can be considered a failure is the cost. So if our service is eating the whole margin, then it might be, problematic for the business, right? If you will take a look at the screen, this is on the x-axis we have requests per second, on the y-axis we have cost of the solution. So as you can see, for the low throughput systems, Kinesis on demand and also on demand with the enhanced fan-out might be more expensive than SQS. But situation is way different when our system is scaling. So if we are getting high throughput, the cost comparison is on the it's way better for the Kinesis. So it's not like the Kinesis is expensive service. I've heard it also many times from the developers, and SQS is cheap. It depends on your use case. So do it wisely and observe your cost always. This is a situation that was in one of the services that in my team. So we had a service. This comparison on the level of about 40 million requests a day. So the cost comparison is way better with the Kinesis. So we have better service to process our data. We can have much more consumers. We are paying for it less, and it's just a better service that we have. So please watch your cost always. If you don't want to how to do it, there's article about under that QR code when I'm writing in comparing SQS with the Kinesis, and also there is a website that I've created with this calculator where you can put your throughput in your system, and it can show you what is the more or less comparison of the cost of different approaches with the SQS and the Kinesis, so you can pick your choice. So key takeaways, something that you can do. I picked a couple of things that are low or no code, actually, and it can improve greatly your processing. So first of all, setting up the data queues for all of your SQSs, failure destinations for all your stream consumers. What you can also do is that you can put alarms for the processing lag, especially including the retention values on your queues, and on any message on those letters that you have created or the one that you have. Apart from that, alarm for the severe throttling on your lambdas and concurrent executions on your account, and turning on bisection. It's the single boolean that you can just add and just add the heavy lifting to AWS. Thank you for your time. Let's get in touch.